Hello everyone, this is another video from Siemens PLC programming, and in this video we are going to talk about the axillary contact and how you could use these axillary contacts in PLC programming. So let's start with the short introduction to the axillary contact and how they works. So the axillary contact, they are electromechanical device that is usually mounted side or front of the contactor. So what I have here and you see on your screen, there is actually the contactor with the axillary contact. So these white section, these two NO and NC, see these two pins for NO and these two for NC. They are actually part of the axillary contact. So it has actually two axillary contacts. And these three that you see, these are actually the normal contacts that we have. So for this case, these axillary connected in the, or mounted on front of the normal contactor that we have. So they physically connected to the contactor, and they able to activate it or deactivate it at the same time as conductor. So as you could see here, so if you take a look to this left side, what we have here is 1, 2, 3, which we call that's the main contacts. So they actually control with this coil that you see, which is A1 and A2. So these two that you see here as a NONC, so they are actually axillary contact, which is controlled with exactly the same coil. So that means these main contactor, these three, so if you active this coil, they will be closed. If not activated, they are open, right? They are normally open, so they are just closed whenever you activate this. But in the axillary, actually, you have normally open and also normally closed. So that means if this coil, which is this coil, is common between the axillary contacts and the main contact that you have here. So this is a main coil. If you active that, these three is close, plus these NO in the axillary that close because that's a normally closed. And these guys here with the NC is normally closed. So that means whenever you active that, that will be actually open. So in other words, if you active the coil, this one, these four, which is three main, one axillary is actually closed, and the last one will be open. So it is, as I mentioned, there is actually the electrical isolation between these axillary contacts and these main contacts that they just connected mechanically. So whenever they move, they're able to change the condition of these axillary contacts that we have. So usually these main contacts, they're able to tolerate the higher power and higher current, but these axillary contacts, they actually tolerate less current and power in compare with the main contacts that you have. So these actually axillary contact is very useful. Here we are going to see the most popular application of them in the PLC program and see how we use these axillary contacts in the different application. Here I mean just for, I'm going to mention to the three main application or popular application of the axillary in PLC programming. So let's start with the first application. So we will have three applications. I start with application number 1, which I call that hold the contactor. So the other name you could find in the different references, maybe you could find the same concept with the 3-wire connection or 3-wire motor control. So they are actually mean the same concept. So let's see what they mean. So as you could see, this is our conductor. These 3 pole is the conductor for our main contactor, which is these are normally open. So we have these stop normally closed switch and these start normally open. So what's happened here, whenever you push these button, you somehow energize these coil. This is normally open, and definitely whenever you energize this, it should be closed. So if you connect this part to your power and here to your motor, so definitely whenever you push this start button, so it's actually turn on your motor. So now question is, how about whenever I release these start? So if I release these start, again, you actually, the current couldn't pass through these switch to start switch. So that means it couldn't be energized. There's no power here. So this actually back to the normal open, and open the conductor and motor actually will be off. So if we summarize, so here with pushing the start button, it's the motor works here. If you release that, it's actually stop or turn off your motor, which is, it is tough whenever you want to use the motor. You actually holding this button for a long time. So definitely we are looking for some way that whenever we push the start button, even if we release that, the motor actually continue to work. So for doing that, so definitely these axillary contacts actually help us to do that. This is what we call the three-wire connection, or this is a way that you are going to hold the contactor. That means I want to just, whenever I push that, the motor works. Even whenever I release, the motor continue to work. So let's see how we could do that. So as you could see here, so whatever you see on the black wiring, this is exactly the circuit that I explained here. Okay, so if you ignore these blue wiring, so whatever I have with the black is the same. So this contactor, main contactor, is normally open. So you have these two switch. Whenever you push the start switch, it's energized the coil. So, and the contactor is closed and your motor start to run. If you release that, you de-energize the coil, so then motor will be off. So with adding this blue part, which is somehow using the axillary contact, you are able to keep contactor on even whenever you release this start push button. So I use actually a wiring, these blue wiring that you see, I connect to these pin of the axillary contact, this section, and I use the normally open. And the other side of this connected to this section, okay? So let's see if we add these two parts, what will be happen. So whenever you push button, nothing change, you energize the A1. So these actually contactor is closed and your motor here is on. So see whenever what you release, so let's see what's happened. Whenever you release that, if there is no these blue section, definitely you de-energize the A1 and this contactor will be off and the motor will be off. But whenever you have this section, if I release this, okay, because when you energize these coil, this is normally open. So whenever you energize this, so technically this is actually closed, right? So that means whenever I push the button, so this one is closed, and somehow I energize these A1 and A2 from these paths that you see. So whenever you release, because this one is still closed, so see, still I'm able to energize A1. So see, A1 actually get this power here and already connected, A2 connected to the neutral. So that means because this is actually closed, even if you release these actually start up, still you energize the A1 and A2, which is your coil, and these main contactor will be closed and your motor still is on. So when you could actually turn off these motors, so that means you push this start button, So it start to work. Even you release these motors start to working because the contactor is closed. The only time you could turn off if you actually push these button. So that means this button is normally closed. So that means whenever you push this, it should be open. So whenever you open, you somehow connect the power. So everything is de-energized. So there is no power here that able to energize these coil. So that means this contactor will be open. So if this is open, so definitely your motor will be off. So if we want to explain the same thing with the ladder logic, we could actually have the control circuit here. So see, this is your hot, your is neutral, or your ground. So I have these normally closed. Stop. This switch is normally open. So see what we have. This is the coil. This is same A1, A2 that you have. Whatever you have here as a normally closed contactor, this is what you have usually inside or attached to the motor. This is overload contactor. Whenever you get too much heat on the motor, usually it's actually disconnect that. So some people don't actually put that here, but just here I want to show, okay, you have that one over there. So let's see how it is works. So in normal time, so this is normally closed. So that means this is closed and you have the power here. So if you push the button, so the current pass through these and energize the coil. So that means you have the power, or your energized coil means it's your conductor is normally closed. So that means this should be normally open. So whenever, so see here is this normally open. So that means whenever you energize the coil, it's going to be closed. So that means if the main conductor closed, you actually turn on your motor. So which is this line is right. Let's see why we have these guys here. If you don't have these here, so again, whenever you release these, start push button. So that means you don't have power here. So the coil de-energize and the conductor will be open and your motor will be open, right? So this part is exactly this blue circuit that I explained over there. So you put these series with these start actually push button, and what's happened whenever you push this, you energize this, and this coil M is on. So this is actually open circuit. This is actually axillary contact of these contactor, which is this one is the coil of that. This is A1, A2. This is actually the normal open axillary contact that you have here, which how you could open or close this, you actually open close this based off these coil that the power of these coil that you have. So that means whenever you push this coil is on. So if this coil is on or energized, so that means energize these normally open. So this is normally open. Whenever you energize, you means you close that, right? So that means because this is power up, this is power up, this is closed. So that means you have another passing the power through these direction that you see. So even you open this, so you still have these directions. So power could actually keep the A1 or A2 or coil active. So your main conductor is closed, and your motor is on. So even if you release this, so the only way you could stop your motor is you actually push this button. So that means if you push this button, this is somehow will be the open. If this is open, no power here, no power here. So this will be off. If this is off, this will be open. So that means everything open, and you don't have any power on the coil, no power on the coil. This is normally open. So that means it's actually somehow turn off your coil. So that means whatever you see here is somehow, this is the ladder logic of the same concept that you have. So this is actually the most important application of the axillary contact. So the second application of the axillary contact, sometimes whenever you turn on and off your motor, you want to have one LED or lamp that will show the condition of your motor. You want to, that LED will be on whenever the motor is on, and the LED or lamp will be off whenever your motor is off. So if you want to have some kind of the circuit, so definitely the axillary contact, you could use the axillary contact to do the job. So as you could see here, we have ABCD, which is these normally open contactor, and this one is the, if I go a little up, yeah, okay, so this one is yeah, no, it's better. So this one is the axillary, these normally open that you see here. These three main contactor, this is axillary normally open one. So definitely if you energize these coil, you are able to close and open this, same with this normally open. So if I energize this, this is normally open, so these three will be closed. So if these three is closed, if you have a motor here, so definitely your motor is on. So in the same time you energize this will be closed too. I just connect the LED or lamp. Here is DC voltage and the other part is the ground. So this is normally open. Whenever you energize, it's actually close these conductor and also close this. Whenever you close this, you have a complete loop and able to turn on your LED. So definitely whenever you de-energize that, this conductor is open. So the motor is off, these two places is also open circuit, and this LED will be off. So that means easily whenever you turn on the motor, this LED is on. Whenever you turn off, this will be off. So that's actually what we have here as a second application for the axillary contacts. So the third one is most popular one. So you could use the almost the same concept, which is the axillary contact, to somehow run the motor in reverse and forward direction. So let's see if I could just minimize that a little bit, that able to have everything in one page, which is right now is good. So you have a motor which you want to add three switch for that. So 3 push button. So the one push button, whenever you push, your motor actually move forward. So you stop that. Whenever you push the reverse one, it's actually go to the opposite direction, which is the counterclockwise. So that means a 3 switch, push button, not switch, 3 push button. So whenever you push one, it move forward, you stop it. Then whenever you push the reverse, it go to the reverse. So again, if you want to back to the forward, first you need to push the stop, then actually go to the forward. So that means anytime you want to move from reverse to forward, definitely you need to push the stop button. So again, it is exactly the same concept that you see in first application. This one somehow is you use that 2 times in the 2 different contactor. Let's see how we could do that. So we have this time, definitely you need to have the two contactor we call M1 and M2. So these are normally open contactors. So definitely for the first M1, if you just, that is the AC one phase actually motor. So in the first M1 you could just connect the hot wire and the neutral wire, and in the M2 you just reverse that. Whenever you change the place or switch between the hot and neutral, definitely you could change the direction. So that means in the M1 you have the hot and neutral in specific place. So in the M2 you just switch their actually places. So that means if M1 is open, so it's actually move forward. If it's M2 is closed, not open, closed, actually the it should be go to the reverse. So that means what's happening in the main conductor, just the place of the pole is the different, and they able to drive your motor forward and reverse. So that's what you see. So M1 conductor, it is again, it's normally open with 3 main contactor, exactly the same format like this. So this is 3 main contactor. We have the coil and normally open and normally close axillary contact. So here I don't put the overload contactor here, so for make that more simple, so here I added, don't confuse, because somehow it's a conductor that you have inside these coil, somehow attach these coil, and you are not doing too much control work with these over load contactor control. So see, this is M1 coil, this is actually M2 coil. So let's to see how it's works. So we put, let me start with the forward button. So we put the, so this one, whatever you see in this line is exactly this one, okay? So just the only thing we use these 2 axillary here. The reason is we want to, whenever we actually, the contactor 1 is closed, so the M2 will be open. And the opposite of that, whenever this is closed, this should be open. So that means somehow use the axillary contact to make sure never these 2 circuits actually work together. So that means whenever you this is energized, this is off. Whenever this is actually power on, so this should be off. Let's see how. So this is start, this is forward, and these open contactor that you see control with these M1 coil. So that means whenever you energize these M1, it means you energize this and will be closed. Whenever not, this is off, definitely this is off too. So these M2 is controlled with these coil of the M2. So that means if you, if this is off, so definitely this is closed. So whenever this is on, so this is actually open. So that's the reason if one of this is on, so definitely if this is on, for example, definitely you make sure this guy is off, right? So if these on, definitely you make sure this one is off. So that means these axillary actually contact make sure you never turn on the both contactors in the same time. So let's go to the more detail. Stop forward M2 M1. So whenever this stop is actually normally closed, so that means the power comes here. So if you push the forward, so its power passed through this, and because this is off in the beginning, so definitely there is no power here. This should be normally closed, and easily power comes here. Turn on these M1. M1 is power up. It means this is closed. So that means similar with what we have here, exactly is the same circuit. So that means you push the forward, the M1 actually is closed, and your motor start to working. Even if you release these forward, still the motor actually turning on. So the only way you could turn off, you should put the stop actually button. So see here, so you stop it, now you want to reverse that. So if for the reverse, so definitely you push these reverse button, so it's actually energize this. You have the power here. So here, because M1 is off, so M1 is off means these closed. So that means you have power here. It's energized the M2 coil. So this control, this is the M2, the axillary contact here. If this is active, this one is active. If this is active, this is closed. So that means with pushing these reverse, so definitely you have power up these M2. So contactor 2 is closed, and your motor start to go to the reverse direction. So similar with this, even if you release, because you have the power through these direction is actually go to the reverse until you actually push the stop button. So that means if you want to move forward, you push this. So if you want to go reverse, even you push the reverse, nothing happen. So you should go first to this stop, then actually push the reverse that able to go to the reverse. Same story for the reverse. Whenever it's turning the reverse direction, so even you push the forward, nothing happen. You should first put this stop, so then you push the forward, it's able to go to the forward. So this is actually third application of the axillary contacts. In next few video that we have, I'm going to show you how could actually implement these ladder logic or these control circuit that we explain here, and we will have all of them in our Siemens PLC. So we will have one PLC program for this, which implement the same thing here, which somehow you start to stop the motor, and the second one is you able to run the motor reverse and forward direction with having 3 switch, stop, forward, and reverse. So stay with me. In next few videos we are going to do that. Thank you so much for watching this video.